Welcome to Train Signal. You are watching an introduction to Cisco's Unified Data Center. So this is an interesting lesson. It's kind of a high-level overview of Cisco's data center strategy. And this is important for a couple of reasons. It's important because I want you to understand how UCS fits into the data center. I want you to understand some of the other Cisco components that make up this data center strategy. And it's important if you plan to take the DCUCI exam, because Cisco on the exam will ask you about other components and connectivities and what your options are. So it's not just UCS, it's how UCS talks to the rest of the data center environment. And that's kind of what I want you to see here. So we'll start with an overview of the Cisco's virtualized data center. Go through some of the components, understanding the components and the pieces and parts. And then a little more detail. Infrastructure components on the Nexus switches, a quick overview of FEX, which is your fabric extender technology, virtual infrastructure with the Nexus 1000V, and another infrastructure component, which is the MDS fiber channel switches. And then finally, just a quick hit on cloud provisioning and automation. Didn't think I was going to let you get through any of these lessons without hearing cloud, so I'm just going to get it out of the way early. So with that, let's get started. So Cisco has developed a line of products and technologies that extend virtualization throughout the data center. Keep in mind that when I say virtualization, and I'm a big VMware guy, I'm all about VMware and consolidation. When I say virtualization, I don't always mean server consolidation. Now, normally I do, but when we're talking across data center, you have network virtualization, storage virtualization, server virtualization. There's a lot of different things. So kind of, when you hear that, keep that in mind. UCS is just one component of this strategy. It's like the compute block. You still have storage, you still have networking, you have all sorts of fabric. There's a lot of pieces and parts, and UCS is Cisco's compute block. It's a good idea to understand how they fit together. It's very important if you plan to sit the DCUCI exam. And then the current approach is known as Data Center 3.0. So Cisco kind of goes through these evolutions and kind of their vision, and this is known as the Data Center 3.0. It's made up of layers, it's made up of processes, it's not just product. Cisco sells product, absolutely, but they want you to kind of work on things like automation as a process. Now they're happy to sell you products that'll help with that, but some level of automation and management, things like that go into this as well. It's not just about speeds and feeds and gear. So this is going to be an extremely convoluted slide. I'm just going to tell you right now, this is a slide that I took from a Cisco presentation, but it just shows the layering of the different pieces of their strategy. So there we go. Phase 1, starting on the foundation, is what they call consolidation. And with this, they've got their Nexus family. And we'll talk about that, but it kind of unifies infrastructure. Unifies Ethernet and storage fabrics together. 10 gig lets us collapse a lot of these 1 gig connections down to smaller 10 gigs. And it's just about consolidation as well as on the server side too. Then virtualization, we've got things like unified computing with UCS. Unified network services, kind of collapsing again some of the network service offerings in the new Nexus operating system, NXOS, and unified fabric. So that's your fiber channel over Ethernet, things like that, to kind of get rid of all that redundant infrastructure. When we talk about that, it's really about virtualizing these services, virtualizing things like fiber channel. Just think about it as giving you a lot more flexibility using existing technologies. Phase 3, automation. So Cisco's got things like Cisco Cloud. They purchased, went out and acquired NewScale. They acquired Tidal, a couple of big names in provisioning and automation. We'll talk about those at the end of this lesson, but it's important to know their names and what they do. And then the last two that they just kind of glob up here is your Phase 4, which is your what we call utility or private cloud, and then Phase 5, which is your public cloud. And so one of the things that I do for Vero is kind of help people kind of move toward the cloud and reach that cloud kind of, utopia that the market keeps talking about. So what we normally see are, first you have to get your components and your technologies in place, your virtualization. Then we have to start looking at how we automate and deploy processes in Phase 3. And then it's extending things into a true cloud, kind of this elastic load type offering where we can expand and contract as needed. and the eventual goal is to be able to push out into a public cloud and pull back as needed. So there's a lot of layers that go into this when people talk about going toward the cloud. Usually there's a lot of fundamental foundation things that an organization has to fix and get in place first before they can get to that level. Key here is, here's your 5 phases: consolidation, virtualization, automation, utility, private cloud, and market or public cloud. So let's now talk about the components of the data center strategy. It's currently undergoing a bit of a revolution. Virtualization, server virtualization, is causing a lot of this. Things like video conferencing is causing some more with the need for more bandwidth and throughput. It's amazing to look at some of the projections for traffic with video conferencing. I think when I was at Cisco Partner Summit, so you'll have to forgive me, it was almost a year ago, they were talking, within 5 years, I think it was, something like that, that video conferencing would use more bandwidth on corporate networks than anything else. And if you look at most organizations, right now that is not even close to the case. So we're starting to see that boom, and I see it in places, especially now with portable tablets and iPhones and things, and now I'm used to being able to FaceTime my family while I'm on the road. People are really starting to take advantage of that. So I don't doubt it. And it's really starting to stress, standard 1 gig infrastructure. So we're starting to see 10 gig going mainstream. My customer base, kind of what I call high commercial, low enterprise, 10 gig is a standard offering now. It's not something that's only for certain things. Now, they're not doing 10 gig to a desktop. It's still data center, but it's still becoming the standard deployment within data center. And it's driven by these new application requirements. It's also driven by virtualization as a catalyst for change. Now I can give you a blade with 40 cores or more and half a terabyte or a terabyte of RAM, and that's a lot of capacity. That's a lot of virtual servers running on those blades, and we need to get a lot of I/O in and a lot of I/O out. And the way to do that is things like 10 gig or 40 gig Ethernet, and not just a whole bunch of 1 gig connections. So virtualization is definitely driving that change with consolidation. It's also causing people to look at automation and cloud, because now I can spin up a VM in minutes. What used to take a project weeks or months to get equipment on the ground and gear in a rack and provisioned is now being done in minutes. So people are starting to automate this process, and we're starting to look at these, again, cloud offerings where I can give an organization or a department within an organization some resources, and they can expand and contract that as they need without getting IT involved. So things become more challenging. They become better for the business, but they can become more challenging for the administrator. So you need to kind of understand the landscape if you want to sit, again, the DC-UCI exam. They will hit on these things a good bit, and I'll kind of point out some things as we go through this that you need to be aware of. And you can also take a look at the exam blueprint, which we cover in a later lesson, and match that stuff up. But I don't want you to be blindsided by going into a UCS exam and being asked about Nexus or Catalyst or MDS. So the first infrastructure component I want to talk about is the Nexus switch. And we'll start with the Nexus 5000. This is the first generation. So many people, as I said just a minute ago, are moving to 10 gig. And some are preparing for 40 and 100. And there's already 40 gig gear out there, and there's some, initial 100 gig gear. But that stuff right now is still very expensive, but it's becoming mainstream. I mean, the new 6200 interconnects are 40 gig capable, which is just crazy when you think about the throughput through those guys down to chassis and then up to the core. But things are driving this sort of requirement, so Cisco's out in front of it. Now, the first gen Nexus 5000s, there were 2 models, the 5010 and the 5020. The 5010 is a 1U switch, 20 10 gig ports plus a module. The 5020 is a 2U 40 10 gig ports plus a module. It's actually 2 modules. We can see that here. It's one on top, one on bottom. So if you look at these switches, this is a 5010. It's got 20 ports right here. The green ports are an add-on module. Over here, we've got 20 on top, 20 on bottom, and 2 modules. So a 5020 is almost like a 2 5010 stacked. Very simple. The modules add other functionality like fiber channel, an additional number of 10 gig ports, or there's combos that add both. The idea of these switches are they're only layer 2, so they do not do any layer 3 routing or inter VLAN routing or anything like that. The idea is they were top of rack switches. the purpose that we've deployed many of these are for fiber channel over Ethernet. So we would have rack mount servers with 10 gig converged network adapters in them, usually run two connections, one to one switch, one to another switch. For a fiber channel array, we would plug those into the fiber channel ports right here. When the servers connect, those unified converged network adapter ports look like a 10 gig Ethernet and a 4 gig fiber channel. So you get data and storage over a single connection, and that's your fiber channel over Ethernet. That's unified fabric. And the Nexus 5000s were the first Cisco switches that supported that unified fabric. These switches have been available for a while now, probably, at least 2 years, longer than that probably, and they're very, prevalent. We see them in a lot of places, still sold as cheaper 10 gig switches with FCOE capability. The successor to that is the 5500 line. So this is second gen top of rack 10 gig. 5548 UP is 32 10 gig ports plus a module. So you get 32 ports, and then you can add a 16 port module to give you a total of 48. And these are unified or universal, just like the new 6248 UP fabric interconnects for UCS. And so you'll hear me flip and flop between unified and universal all the time. I've seen it both ways in Cisco documentation, so forgive me for that. But it allows you to start with 32 and add 16. Now, whatever port SFP you plug into those ports, it can do it. So it can be a 1 gig port, a 10 gig port, a 8 gig fiber channel. So pretty much anything you want to do with the ports, you can do that. The larger model is a 5596. It's a 2U, starts with 48 ports, and has 3 modules to add up to another 48, so 16, 16, and 16. These have optional layer 3 capability. They're actually pretty good for layer 3 functionality. I mean, we've deployed a couple of these as small layer 3 core switches for small environments, mainly when a customer is moving to all UCS for servers, needs some 10 gig for other things, and then maybe has some 1 gig switches for some other things. Usually we use, as I'll talk about in a minute, Nexus 2000s for those. And these make great little small data center 10 gig switches. Also used to add 10 gig to existing environments. So if someone has 6500s and they don't want to replace those yet, but they need some 10 gig modules for, say, a 6500 Catalyst chassis switch are very expensive and not real dense. We'll add these for those as well. So very flexible, have a lot of great use cases, and these have been very, very popular. Also, the new 6200 interconnects are based on the 5500. If you look at them, you'll see that. The 6100 first gen interconnects are based on the old 5000 platform that I just talked about on the previous slide. So it's not exactly the same, but if you look at the hardware, you look at the modules, you see that it's based on these switches. Then there's the big boy, which is the Nexus 7000 line. There's 3 of them down at the bottom. There's a 7004, which is your 4-slot option, 7009, which is a 9-slot. It resembles a Catalyst 6500 in looks and size, which is why they have that. A lot of people think that's odd, seeing as there's the original 2 released were the 7010, the 7018. 7009 isn't really, it's only 1 slot smaller than a 10, but it's a good bit smaller on the physical footprint. They've shrunk that switch down so it looks like it's kind of like a 6509. The original 7010 takes up almost half a rack just by itself. So these are very fast, very expandable, and you can do in-place upgrades to backplane switching speeds using what we call fabric modules. So on the back of the switches we have fabric modules. We can add more modules to add more backplane speed, or replace them or upgrade them with 2nd or 3rd gen fabric modules for even faster speed. Here's kind of a step out of the 9, the 10, and the 18. At the time I'm doing this video, the 7004 isn't actually out yet. It's been announced but not shipping, so I don't have good slide for that. The 4 is going to kind of be a special use case, given that it's only 4 slots and 2 of those are going to probably be taken by supervisor modules. Very specific. What we're seeing for most data center cores are going to be the 10, the 18, and the new 9. Slots, 7 plus 2 soups, 8 plus 2, 16 plus 2. Gives you your rack requirements. Right there's one reason we see the use of the 7009. 14 rack units against 21 from the 7010. And there's the 1st and 2nd generation fabric modules. So the 1st generation was 230 gig a slot maximum. 2nd generation on these is 550 gig per slot. So a great increase in backplane speed. The 7009 never shipped with the first gen, that's why it's not there. But the thing to keep in mind, 7000 series is your very dense 10 gig core. Your 5500s are kind of your top of rack type switches, unified fabric, some layer 3 functionality that's requested at the access layer or small core, but the 7000 is your big core. There's also the Nexus 2000. These are kind of your top of rack connectivity. So these are not true switches, meaning I take a 2000 out of the box, I plug it in, I power it up, it's not going to do anything. It's dumb. It's what's known as a fabric extender or FEX. And you're going to hear FEX a lot in this course. We talk about all sorts of different FEX or fabric extensions in this course. So it's not a true switch. It must be connected to a 5K or a 7K. The 5K or 7K does the actual switching. So if something needs to happen on the 2K, it sends it back home to the core switch. It makes the decision and it comes back. But these are cheap, they're easy, and the neat thing about plugging these off of a 5K or 7K is they look like a module off of one of those. So you can take a Nexus, a pair of 5500s for example, as a small core, and then we'll put Nexus 2000s in top of rack for legacy 1 gig connectivity. To manage those, I SSH into the 5500s. Then I can manage all my Nexus 2000s. I don't have to do them as individual switches. They look like modules off of those switches. So it's really a neat configuration, very low maintenance, very low management. There's a range of models. 2148T, which has 48 1 gig connections and 4 10 gigs. The 10 gigs are to run back to the core. There's a 24, a 48. There's a 2248 TPE, which is the same as the TP, meaning it has, it's 48 1 gig connections, but it's enhanced for higher workloads with higher buffers. You've got 10 gig Nexus 2000. So you've got like a 2232, which has 32 10 gigs that can also do FCOE, and it has 8 10 gig ports back up to the core. And then you have a 32, what's called 10 gig base T. So if you want to run 10 gig over standard Cat6 copper, there's one of those. A couple of things. The biggest one here is there's a 2148 and a 2248. The 2248 is a second gen. Highly recommended to go with those. They're better. They support some things the 2148 does not. But other than that, it's basically pick your configuration, and that's the 2K you go with. And just from a reseller point of view, if you're looking at 7000s or 5000s and some 2000s, make sure that whoever you're looking to purchase from looks at bundles. There's some great bundles with 5500s and some 2Ks. You can build out a data center very, very reasonably. So let's talk a little bit more about FEX. FEX is a technology, and it's also a term that gets thrown around by Cisco a lot. It means fabric extender. The bottom line you need to know about FEX is FEX really just means that a fabric is extended by using another device, an adapter, or software. So it really means that one thing is kind of controlling or extending the fabric for another. So if I have a 5500 Nexus and a 2000 2K switch off of it, the 5K is using FEX or fabric extension to the 2K. 2K is an extension of the 5K. Several types of FEX. Switch FEX, the example that I just gave you. There's adapter FEX. We see this with UCS. Split a physical adapter into multiple logical adapters. Those logical adapters are extensions of the physical. And we'll talk about this in the components and other lessons, but there's a virtual interface mezzanine card that can go into a blade. On that blade, I can make that single card look like 50 network cards or 50 fiber channel HBAs using this FEX technology. And then we have VM FEX. So it extends the adapter FEX to a virtual machine. This is where things get a little bit confusing, and we have a lesson on this that talks about this in depth. But I can take adapter FEX, take that one IO or mezzanine adapter, split it into 10 Ethernet adapters, and then kind of just insert those into a virtual machine. So instead of using, say, VMware's NIC drivers or NIC connectivities and virtual NICs, we actually are extending the hardware into the VM, and it's called VM FEX. And we'll go into that again in more detail later, but it's very cool because really it lets you control VM NICs, virtual machine guest NICs, from UCS Manager and the Fabric Interconnects, and the switching is done on the Fabric Interconnect, not on the software switch on the VMware host, which offloads that from the host, and gives us additional functionality by being able to do it in hardware. It can be confusing, and the terminology has evolved. We hear terminologies like VNLink and VMFX and AdapterFX and SwitchFX and all sorts of things. But just understand that it basically means we're extending a fabric, we're controlling it in one place and extending it down without adding overhead or management. So here's a quick just kind of drawing of AdapterFX and VMFX. This will probably make more sense as we get into that lesson later, but AdapterFX splits a physical NIC into multiple logicals. Take that one NIC and split him out into 20 Ethernet NICs. VMFX extends the adapter all the way through to the virtual machine. And so it's really cool because now we can just go ahead and send it all the way through the hypervisor, and all the switching is done in hardware. We get a single point of management because I can control all this from one place, increase 10 gig bandwidth throughput, we're not worried about hypervisor, and I can do all sorts of dynamic network and security policies that we can't do just with, say, VMware Hyper-V itself. You know, we're going to talk about this as it applies to UCS later in the course, but we're seeing this come up in other places. You know, you'll be able to eventually manage NICs from a Nexus switch through to, say, a rack mount server and into a VM, and we're already looking at that capability with some of the new adapters by Cisco. So it's not just a UCS thing, but we're going to start seeing this for other non-Cisco servers as well, using some of the next generation, you know, converged network adapters or HBAs and things like that. So we're kind of pulling some of this functionality out of the hypervisor and moving it back to the physical network, where some people argue that it should be. It gives us better control and better performance. Next piece of infrastructure is virtual infrastructure, and this one is kind of near and dear to my heart. If you look at my blog, jasonnash.com, or if you go to VMworld, the last, for 2010 and 2011 VMworlds, I did sessions on the 1000V. So the 1000V is a Nexus switch that runs in software. It runs as part of the VMware environment. There's announced support for Hyper-V. Right now, as of this recording, everything is all VMware. But what it does is it really replaces the network switch that you get with VMware. So instead of managing a distributed virtual switch or the standard vSwitch in VMware, we replace that with a switch that runs Nexus or NXOS. And there's two components to it. There's a virtual supervisor module and a virtual Ethernet module. And we talk about this later on in a lesson where it's the same one where we talk about VMFX in more detail. But it replaces that switch with VMware with one that's Cisco, with Nexus. So it moves the network back to the network team. The network admins get their visibility and control back. They now can log in and manage things just like they would a physical switch. They can do show interface commands. They can put access lists. You can do QoS. You can do all sorts of queuing policies. It's very, very powerful. And again, we'll talk about the components and the architecture later on. I'll tell you now, Nexus 1000V is spelled out very clearly in the blueprint for the DCUCI exam. Make sure you pay attention to that when we get to that lesson later. It is important. There are numbers of questions on the exam about the 1000V. And just another quick slide from Cisco, kind of this virtualization awareness at scale. I think that's a terrible kind of, title, but it just shows you that there's flexibility. We can do a lot of really cool things with the offerings from Cisco. On the left, we can do 1000V, which is your software hypervisor switching. Feature set, flexibility, that switch does about everything. I mean, it does, again, access lists, QoS, queuing. They also have virtual versions of their WAS acceleration and ASA firewall that plugs in to the Nexus 1000V. Very extensible. And then we also have an option for VMFX. This is kind of either or, and again, I'll talk about it more later, but it's either or, where we can do things where we control the VM adapters from a switch, from a Nexus 5500, from a Fabric Interconnect in UCS, and we get really good performance with hardware-based switching, and you're going to see some things there. Eventually, down the road, I'm sure these two things will merge. We'll be able to use the 1000V with hardware switching, but we don't have that capability yet. Just understand, really, that the 1000V gives you a lot of feature flexibility, but it's a software switch. VMFX gives us good performance and hardware capability, but it's not as feature rich as, say, the Nexus switch. And then the MDS switches. So the MDS line has been around a long time. There's nothing really new here. The newest things in the MDS line are the fact that we can now put fiber channel over Ethernet modules in a lot of these switches and kind of use them as a gateway back and forth. But other than that, it's really not anything too major. I just want you to understand that there's two lines of the MDS series. There's the 9500 line. That's what we call director class. That's those big chassis switches sitting in the middle on the right. 9506, 9509. Then we have the 9100 series, what's called the departmental switches. These are really fixed configuration. There's the old 9124, kind of the old 9134, and the new 8 gig capable 9148. But those are departmental switches, fixed configuration. The 9500 series are chassis based, what we call director class. Then there's a kind of an oddball, the 9222i. He is what we call a service switch. So we see these as point solutions for things like if you want to replicate between two fiber channel arrays, we do this for fiber channel over IP encapsulation. If you want to add encryption, it can do that. Not normally seen as a standalone switch because it's only 2 slot. There's not a lot of density in that switch. It's very expensive for what it is. Some of those functions like replication and encryption you can absolutely do on the director class by putting in the right modules. But oftentimes people don't want to use up space in those switches. They rather have a dedicated service switch, and that's the 9200 series. So again, director class, departmental, those are the things to keep in mind when you're kind of looking at the overall strategy. And then cloud provisioning and automation. So over the last couple of years, Cisco's made some very key acquisitions. They've acquired Tidal and NewScale. So NewScale is now known as Cisco Cloud Portal. It kind of gives you a services menu, self-provisioning for private cloud, manage the lifecycle of services, as well as doing chargeback. It's kind of a competitor to vCloud Director with the chargeback add-ons and the provisioning and those sorts of things. So we've started to see some uptake in this. NewScale is a great product. Cisco's really pushing it. And the nice thing is that Cisco's offering, as compared to, say, VMware's vCloud, Cisco's going to be more open to other hypervisors. So you'll be able to have other hypervisors under that umbrella and provision services accordingly. And then there's Tidal, which is used for automation and orchestration. This is a really neat product. If you ever get a chance to get a demo or take a look at Tidal, you should do that. The drag and drop interface is really neat. You can drag and drop and do things like, okay, now I'm going to drop a block here, and this block here is going to kick off a script that logs into an MDS switch and does zoning like this, or logs into a Nexus switch and sets up a VLAN and does this, this, and this. It's really cool. For somebody like me who can't script my way out of a paper bag, it's a really great interface, and it has, it's kind of a Cisco product now, so it has really great integration into UCS. So NewScale is your cloud portal, your self-provisioning for virtual environments for private cloud, managing lifecycle. Tidal is your automation and orchestration system. And Tidal doesn't have to be used with, say, virtual environments. You can orchestrate and automate all sorts of stuff with Tidal, all sorts of deployments. And we see these mainly in larger organizations, though we're starting to see people request things like NewScale in the smaller orgs. Usually Tidal is an enterprise organization type of product. But again, both of them are very nice, and they really fit in with what Cisco is trying to do with the rest of the strategy. So that's it for this lesson. Hopefully you found it, informative and useful. I know it's a soft lesson to kind of start early in the course, and the reason again is that you need to understand how the pieces and parts fit together, especially if you're going to sit the DCUCI exam. So in this lesson, we did Cisco's virtualized data center, kind of gave you an idea of what I'm going to talk about and how. Understanding the components, a quick snapshot into the different layers and the different components and the pieces and parts. And then we dove in and talked specifically about the Nexus switches, the 5000, the 5500, and then the 2000s and the 7000s. Then I gave you probably a confusing overview of FEX or fabric extension. We'll talk about this a lot as we go through the course because you'll hear me say the I/O modules in the back of a UCS chassis are FEXs. meaning they really are managed by the interconnects, but they live in the chassis, so we use fabric extension. The Palo or VIC 1280 mezzanine adapters on a blade are FEXs because we can split and slice and dice those up into logical interfaces, etc. And again, we have a whole lesson really around the 1000V and the VMFEX. So we talked also again about 1000V. It's Cisco's software switch. It replaces the VMware switch that comes with the VMware hypervisor and gives you a Nexus or NXOS based switch and really kind of gives the network back to the network team. Last component was MDS. MDS hasn't changed in a while. I mean, there's evolution like the new 9148 switches or the newer 9148s. But again, they're all MDS. They're fiber channel switches. Just understand the difference between departmental and director class. And finally, cloud provisioning and automation with NewScale and Tidal for your cloud provisioning, your automation, your chargeback with NewScale, and now with Tidal we have this really great orchestration and automation system. So that's it for Cisco's strategy. Again, I hope that was informative and you got good value out of that. And now we're going to get ready to really start jumping into UCS as a whole. So let's get started on that. Thank you for watching, and I'll see you on the next one.